word linear describes a straight line. As you may already know, linear graphs have a general equation y equals mx plus c. X and y represent the value of the x and y coordinates along the straight line. M represents the gradient or slope of the graph, which tells us how steep it is. C represents the y-intercept. This is the point where the line crosses the y-axis, so x will equal 0 at this point. If we are told the equation of a linear graph, m and c will have numerical values. This allows us to find values of y when our x-coordinates are known.
The equation of a graph is y equals 2x plus 1. Here, m is 2 and c is 1. Let's draw this graph to satisfy the inequality negative 2 is less than or equal to x, which is less than or equal to 2. This means the straight line will be drawn between the x values of negative 2 and 2 on the plane. We need to set up a table of values for x and y. We can fill out the integer x values within the given range. To find each y-coordinate, just substitute each value of x into the equation of the graph y equals 2x plus 1. We need to do this for each value of x separately to find the corresponding y-coordinate.
So we can see that the value of y increases as the value of x increases. Once you have filled the table out, it's just a matter of plotting each point onto the plane as a clear x mark, and then joining up the points with a ruler.
If we are given the graph already drawn, we could be asked to find the gradient. There are two ways we can do this. We can show it using the graph, or pick 2 points from the graph. Here we will use the equation we have started with, which is y equals 2x plus 1. Looking at this equation, we can see that the gradient is 2, so let's prove it using the following methods.
First, choose any 2 coordinates from the table we created. For example, -2, -3, and 2, 5. The formula you must learn to calculate the gradient is y2 minus y1 all over x2 minus x1. Our first coordinate can represent the point x1, y1, and our second point can be x2, y2. Substitute the values into our formula, being careful with the negatives, and we get 5 minus -3 divided by 2 minus -2. This simplifies to 8 divided by 4, which is 2.
We know this is correct. The only part of the equation left to prove is the value of c, the y-intercept. Using one coordinate, let's use 2, 5, and the gradient, which is 2, we can substitute this into the general formula y equals mx plus c. This gives 5 equals 2 times 2 plus c. We need to solve this for c. If we simplify the equation, we get 5 equals 4 plus c, so c must equal 1. Now you've formed the equation from 2 given coordinates.
The second method of finding the gradient is using the graph. So look at the graph of y equals 2x plus 1. Using the same coordinates from the previous example, form a right-angled triangle. Using the formula m equals delta y over delta x, meaning gradient is change in y divided by change in x, we can see that our change in y is 8 and the change in x is 4. 8 divided by 4 equals 2. You can see that the graph crosses the y-axis at y equals 1, so the y-intercept is 1. This is our value of c. Practice using both methods to draw a graph or form the equation of a graph.